When making materials in Blender, we often use generated object and UV coordinates. But how do they actually work, and when should you use them? That's what this video is about. Let's get started. Textures in Blender are mapped using a texture coordinate node. Generated and object are 3D coordinate systems. That means that textures are evaluated at each point in 3D space. They're mostly used with procedural textures such as this noise texture. Generated fits the 3D space inside the object's bounding box and maps the texture across it. Textures follow armature and modifier deformation based on the undeformed coordinates. However, the texture is always based on the bounding box. This makes consistent scaling of the texture on objects with different sizes and proportions difficult. Object coordinates, on the other hand, map textures infinitely in all directions. They stay fixed in space during deformation based on the object's origin. This is useful for consistent scaling of the texture across different object sizes and proportions. You can also use the coordinates of another object, such as an empty. The texture is then mapped based on that object's origin. This can be used to place or animate textures across one or multiple objects. Procedural textures work well with 3D coordinates because they are calculated directly in 3D space. Generated and object provide a 3D position for each point on the mesh. Procedural textures use that position to generate a color. However, problems occur when we start using images. Say for example I have this color grid image in an image texture node. Images are not functions that can be calculated at each point in 3D space. They only exist as a 2D grid of pixels, so they must be projected onto the model from one or more directions. How they are projected depends on the projection method. Flat projects the image from one direction. By default, it's projected from the top along the X and Y axes. That's why the texture stretches along the sides. We can use a mapping node to rotate the image by -90 on the X-axis. Now it's projected from the front, making the mapping clearer. Generated is mapped within the bounding box from 0 to 1. Object is mapped from the object's origin, but the texture is still stretched along the other sides. To avoid this, you can switch the projection method to box. This projects the image from both directions on each axis, also called Tri-planar Projection. To remove seams between the different projection directions, increase the blend value. With this, you can apply image textures to 3D models without manual UV unwrapping. However, it has downsides with armature and modifier deformation. Generated can stretch the projected image when the object is deformed. Object will keep the projected image fixed in space and not follow deformation at all. That's why this method is mostly used for static objects. To achieve high texture quality that works with deformation, you need UV mapping. A 3D model uses X, Y, and Z coordinates in 3D space. UV mapping is the process of converting those coordinates to 2D space. The coordinates in 2D work like X and Y, but to avoid confusion, they're called U and V, where U is horizontal and V is vertical. This 2D layout is called a UV map. Once we have a UV map, we can use the UV output of the texture coordinate node. With projection, the surface is flattened from one or multiple directions into 2D to sample the image. Then the results are blended together. However, with UVs, box projection is not necessary. Each position on the mesh already has a 2D coordinate, so we use the default flat projection, which uses the X and Y coordinates. In UV space, X and Y correspond to U and V, so the correct part of the image maps directly to each position on the mesh. The benefit is that the texture deforms with the mesh, unlike object coordinates. At the same time, it avoids the stretching that happens with generated coordinates. UV coordinates are also useful for precise placement of images like logos. Because the coordinates already exist in 2D space, the logo can be mapped directly on top. You only need to scale and move it along the X and Y axes to place it exactly where you want. The logo can also wrap around surfaces along the UVs without any issues. The placement is, however, affected by stretching and seams in the UV map. Projecting images using generated or object coordinates with flat projection is more limited. They can look fine on surfaces facing the projection direction, but as the logo curves away from that angle, it starts to distort. The image also projects through the object, showing on the opposite side. These issues can be reduced, but not fully avoided with 3D projection. UVs are also necessary for texture painting. This is because texture painting requires a new image to store the color. Without UVs, there will be no link between the mesh and the image. If you try to texture paint without a UV map, you'll get a warning message. So you need to UV unwrap first, then you can texture paint. However, you don't actually need a texture coordinate node for it to work. Blender uses the active UV map automatically by default. The texture coordinate node is only needed when you want manual control over the UVs, for example, when using a mapping node. That's less useful for texture painting since the paint is already in the correct place, but it's useful for transforming PBR textures or logos like in the previous examples. Finally, UVs are necessary for baking textures. Generated and object coordinates are great for quickly creating textures for different situations, but they can become performance intensive once many textures are layered together. They might not follow deformation very well. You might also want to export your models to other software such as game engines. In those cases, the textures need to be baked into images. This creates a lighter texture that follows deformation. It's also less computationally expensive and lets you export the texture outside Blender. That's it for this tutorial. I hope this video gave you a clearer understanding of texture coordinates and UVs. I'll explain UV unwrapping and baking in more detail in future videos. So if you find my tutorials helpful, feel free to like and subscribe. See you in the next video.